Are in geometry, lesson 58, titled Tangents and Circles, part 1. Okay, Tangents and Circles, part 1. Let's go ahead and we'll do some reading here. Let's see, if I can get someone to read, and I'll probably repeat this so that it'll end up in the recording, but so that we're getting a little bit of practice reading. Aaron, would you read that first paragraph next to new concepts? Okay, we're working on getting there. Tangents and Circles, part 1. Okay.
A tangent line lies in the same plane as a circle and a circle at exactly one point. A radius of a circle drawn to a point and tangency used as the tangent line
And I'm getting some of that written up here. A tangent line lies in the same plane as a circle and intersects the circle at exactly one point. That's important. A radius of a circle drawn, it helps to be able to type, drawn to a point. You try to type and talk at the same time. Point of tangency meets the tangent line at a fixed angle. Okay? All right, then we're going to get into Theorem 58-1. Theorem 58-1. Let's see. Darian, would you mind reading Theorem?
If the line is tangent to a circle, then the line is perpendicular to a radius of
Okay, if a line is tangent to a circle, then the line is perpendicular. Okay, what's perpendicular mean? Yeah, two lines that are perpendicular do intersect, but they intersect very specifically. How do they intersect? At 90-degree angles or a right angle, perpendicular to a radius drawn to the point of tangency. Because how many radiuses or radii can I draw in a circle? An unlimited number of radiuses or radii. Okay? So if I have a circle and I've got a tangent, well, somewhat tough to draw a line that touches a circle at exactly one point. Okay, let's call that a tangent line. Let's make it look a little bit more like a line. Okay, let's call that my tangent line. Here's the center of my circle. Now I could draw any number of radii through here, but there is going to be one radii or radius that's going to intersect that point of tangency at a right angle. Okay, and because that tangent line is only intersecting that circle at one point, that one radii that's going to connect to it will meet it at a right angle. Okay, let me read it again. If a line is tangent to a circle, then the line is perpendicular to a radius drawn to the point of tangency. Okay? All right. And you see a nice picture there on page 381. Okay? All right, then they're showing you that EF is perpendicular to DG. All right, let's look at Theorem 58-2. Theorem 58-2. Let's see. Darian, do you want to pick somebody else?
If a line in a plane of a circle is perpendicular to the radius at its endpoint on the circle, then the line is tangent to the circle.
Okay. If a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. Okay, that is essentially the converse statement of theorem 58-1. Okay, the other one said if a line is tangent to a circle, then it's perpendicular to the radius. This one says if it is perpendicular to the radius, then it's tangent to the circle. They go back and forth. One already knows one part of it, therefore proves the second. All right, the other one says we know the second, therefore it proves the first. Okay, leaving us finally with theorem 58-3. Theorem 58-3. Brady, pick somebody else. Okay, Caleb? Who? Okay, if two tangent segments are drawn to a circle from the same exterior point, then they are congruent. Okay, and they do a pretty good job of giving you a picture here. Let's see, let's draw us a circle. Okay, it's a tangent segment, which means that these 2 points, let me be a little bit more clear. If that is the point of tangency, okay, what they're saying is that those individual perpendicular segments are congruent to each other. Now, I haven't done a great job of drawing my picture here, but if I label this A, B, and C, what we're saying is that segment AB is congruent to segment CB, that these two are congruent to each other if they come back to the same exterior point. If two tangent segments are drawn to a circle from the same exterior point, then they are congruent to each other. Okay, so if I knew that AB was 7, what would I know that CB was? Right, and I can use the same thing algebraically. If I knew that AB was 2x plus 3, and I knew that CB was 5x squared, right? I could set them equal to each other and solve for x. And I'm just giving you a random type of situation, but I would end up setting those segments equal to each other in order to solve for x. And then they may say, hey, what is the length of AB or what is the length of CB? Then I would plug x back in and I would solve. All right, so with that, let's go ahead and start solving some questions. Okay, lesson 58 here. We want to find the point of tangency and write the equation of the tangent line through this point. What is the point or the coordinates of the point of tangency here? Okay, anybody know? Mick? 3, 0. Okay, he's showing me that B is the point of tangency, right? B is where the line is touching both circles at exactly 1 point, and that coordinate location is at 3, 0. I'm going over 3, I'm going up or down none, 0. Okay, the equation of the line. The line is here. What type of line is that? Can anybody tell me? What type of line is that? Not just a tangent line, but it is a vertical line. And vertical lines have what type of equation? Are they y equals or are they x equals? X equals. And it goes contrary to what we would normally like to think, because we think, okay, the y-axis is a vertical line. Okay, but the y-axis is actually the line x equals 0. X equals 0 is the y-axis. I know that goes backwards to what you would think. And the x-axis is y equals 0. Y equals is always a horizontal line. X equals is a vertical line. So what this is going to be is x equals, and then what the x coordinate is, in this case 3. So that means no matter what y is, x always equals 3. Okay? So we should get, I want to say, should get A for our answer there. Do we understand that question? Do we understand the answer to that question? Hopefully. Okay? All right. Let's come down to number 2. Now, number 2 is going to be based upon our last theorem, right? AB and AC are tangent. That's important. Okay? Our tangent to circle P, we want to find the length of AB. So what do I need to do? Okay, go ahead, take it, Caleb. Okay, set them equal to each other. So what equation am I going to write to begin to solve? Okay, 3y plus 4 equals 11y. Very good. All right, what do I do from here? Subtract 3. Let's be more specific. Not just subtract 3, is it? Subtract 3y from both sides. So we want to get our y's together. So I have 4 equals what? 4 equals 8y. Now what? Divide by 8. And the natural tendency here is because we're thinking that y is going to be a whole number that we would divide by 4 somehow. Okay. What does y actually equal? 1/2. Very good. All right. And you'll see a bunch of people will circle B and move on with life. Is that the final answer? No, because what do I need to do? I need to plug 1/2 in. Now, it says find AB. Let me ask you real quick. Do I have to plug 1/2 into 3y plus 4? Why not? Because they're congruent. What's going to be a whole lot faster for me to do? 11 times 1/2. And I'll warn you that this question will be on a test, right? But this is the work that you need to show. What's 11 times 1/2? Left as an improper fraction. Equals 11/2, because 11 times 1 is 11 over 2. So I'll actually get A, but a bunch of you are going to put B. Okay? Just preparing you for that. Okay? All right. All right, number 3. Number 3. Scroll down here. Oh, this is a good question. This is on several tests. This requires us to be able to draw a picture and to be able to draw it correctly. Hopefully I can do this. Okay, a space shuttle is 50 miles above the Earth. An astronaut on the shuttle sees the sun rise over Earth. Okay, to the nearest mile, what is the distance from the astronaut to the horizon hit? The radius of Earth is about 4,000 miles. I think one time in one of my other classes we calculated out, it comes out to like 37 something, but we're going to use 4,000 miles for this. So the first thing I want to do is I'm going to draw the Earth. Okay, not a very good, it looks more like a bean, but that's fine. Okay, we are 50 miles above the Earth. Okay, so if we want to, we make the center of our Earth. Okay, we put our little astronaut right there. And what we're going to have, I'm going to show you what you're going to do and why it's wrong. Can I do that? Okay. What we're going to have a tendency to do is say, okay, well that's 4,000 right there, and that's 50, and there's this, and that's a right angle. So if I know that's 4,000 also, so this is the hypotenuse. And that's wrong. Okay? Because your tangent line is that ray of sunlight that's coming across, touching the horizon and shooting over it, touching it at exactly one point and moving on. And if you'll remember, the tangent line is the line that's perpendicular. Okay? So if I can draw this a little bit bigger, I don't know, I may need to. Actually, let's go ahead and make this bigger so that you can see it. Okay? We're going to do this again. Okay? That my ray of sunlight comes out here. Here's my sun over here. Hopefully not that close. Okay? It is tangent or perpendicular to my radius. My radius is the same everywhere. It's 4,000 miles, right? Okay? Now, my radius is still 4,000 miles, but my astronaut is 50 miles above the Earth. We are asking What is that? Okay, now I can use the Pythagorean theorem, but not the way that I was going to do it before. Okay, what is my hypotenuse here? 4,050. Okay, over here what I'm getting is I'm getting x squared plus 4,000 squared, right? Okay, so these are going to be some pretty big numbers, right? And that's squared also. Sorry about that. All right, so I've got x squared. 4,000 squared, is that like 16 million? Could be wrong. Somebody help me out. 16 million? Are we almost out of time? You guys are acting like some of you are packing up. Well, then help me out real quick then, because you probably want the answer to this if you know it's going to be on the test. 16 million. Okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, 4,050 squared. What's that? 16,402,500. Okay, what do I want to do with this 16 million over here? I want to subtract the left side 16 million. I should get x squared equals 402,500, and then I'm going to want to square root that. Okay? Okay, your answers there should be 634 miles. Okay, you guys have the answer to the rest of those questions. I think we only missed probably the last 3. Okay?